Hello class, in today's lesson we're going to talk about least common multiples. And when do you need these common multiples? When we're adding or subtracting rational expressions or fractions. So let's go ahead and get started. And before we get started, let's talk about a few rules. Basically, all factors that you find when you're comparing these numbers, so different numbers, to find the least common multiple must be represented at least one time. And the second rule is that the factors that you find, you're going to use the one with the highest power. And let's talk about how that's done. Okay, right now it might not make any sense to you, but let's go ahead and get started. There's three categories in which we're going to find the least common multiple. One of them is constants, the other one is variables, and the other one is polynomials. So suppose, like with constants, we have something like 2 over 20, and then plus, I don't know, 5 over 30, and minus 6 over 40. Okay, suppose we have a problem like this, in which we have three different terms or three different fractions that we're adding together, and they have differing denominators. Now, before we can add these together, we actually have to find a common denominator, and the process by which we do that is called least common multiple. Alright, so how do we do that with this particular problem? Well, we're going to start with 20. And what we're going to do is, with 20, what we're going to do is we're going to factor it using prime factorization. So, let's break that down. So this becomes 2 times 10, and then this also becomes 2, 2, and 5. Okay? So we've broken it down to 2 times 2 times 5. Now I'm going to rewrite this into 2 squared times 5. So now for number 20, my factors are 2 squared and a 5. Okay? Now we're going to do the same thing for 30. And before we do that, let's go ahead and make some room. I'm going to erase this. We don't need this right now. Hopefully you've written it down. If not, you can just rewind this video and get back to the other one. And let's do it in a different color that way. It's easier to erase. So with 30, okay, what we're going to do with this one is we're going to break that down also using prime factorization. And this becomes basically 3 times 2, right, times 5. I went ahead and skipped a step. Alright? So 3 times 2 is 6 times 5 is 30. Alright? So for 5, what we're going to have is our factors are going to be the 30. And I'm going to write that in black over here. It's going to be a 2, a 3, and a 5. Those are our factors for 30. And we're also going to do it for 40, so we'll just go ahead and put that down here. Alright, so let's go ahead and break down 40. Go ahead and erase whatever this is right here. So we've done all of them. Alright, so for 40, we're going to break that down. That'll become 4 times 10. Right? This becomes 2 times 2. This becomes 2 times 5. Alright? And since we have 3 2's, we're going to rewrite this as 2 cubed times 5. So our factors for 40 is going to be 2 cubed and 5. So I'm going to write that down over here. And once again, I'm going to keep my color coordination the same. So this is going to be 2 cubed and a 5. Alright? Now at this point, what we've done is we've broken down each one of our numbers using prime factorization into their factors. And so here's what we found. So basically these are all of the factors for all of the numbers that we are comparing or looking for the least common multiple of. So according to our rule, all factors must be represented at least once in our least common multiple. So that is what we're looking for now. Right? So let's go ahead and write that down. So for a least common multiple, okay, we're going to have to write down our factors that we found between these three numbers at least once. Well, here's a 2 squared here, a 2 here, and a 2 here. So there's a 2 in all of them. So we're going to write that at least once. Okay, and then here we've got a 3 sitting by itself. So we're going to write that at least once. Okay, and we got a 5 and a 5 and a 5. But we're only going to write that once, even though it occurs 3 times. Now, that basically takes care of our first rule. All factors must be represented once. Okay, the second rule is that the factors with the highest power is what we're going to use in our least common multiple. So how do we do that? Well, if we look for the 2's, right, we've got a 2 squared, a 2 to the first power, and a 2 to the third power. Since this one has the highest power, we're going to use that power for the 2's. Okay, and then the 3 here is a power of 1. We don't see it, but it's there. Okay, but it's the only one, so it's to the first power. And of course over here we've got 3 5's, but all of them have the same power, which is 1 that we can't see. Alright, I'm just going to write that down on there. So basically that stays as 5. It's 5 to the first power. So now for our least common multiple, what we got to do is we're going to multiply all these numbers together that we found. Okay, and this becomes 8 times 3 times 5. So 8 times 5 is 40, times 3 is 120. So our least common multiple, okay, is going to be 120. So as it stands, okay, when we're looking for a common denominator between these 3 terms or between these 3 fractions, our least common denominator, okay, is what we call it. Okay, that's actually the result. The least common denominator is equals to 120. So all of these different fractions are now going to have 120 for the new denominators, which we'll get into in some other videos, but not this one. All right. Now, let's move on to the next part. That was just dealing with constants, all right? So I'm going to erase all of this because I'm going to need this room. Okay. Now, with variables, okay, basically we still follow the same rules when we're looking for the least common multiple. Okay, because you can have variables that ends up in the denominator of a fraction. All right. Now with this, it's a little bit easier simply because we don't need to try to factor it because we can already see our factors. It's already broken down for us. It's just, you see what I mean? So here we've got for our least common multiple. Okay, we've got an A and an A here, so I need to represent that at least once. We're looking at this rule now. Okay, there's a B and a B here, so we're going to write that down at least once. There's a C here. It doesn't occur here, but we still have to write it down at least once, right? Because it occurs somewhere. All right. Then there's a D in both of them. You have to write that down at least once. And then there's an E here, not here, but you have to write that down at least once. That gets into all factors must be represented at least once, which we've done here. Okay. The second rule is that the factors with the highest power is what we're going to use for our least common multiple. So we got an A and an A cubed. We're going to use the A cubed there. All right, and then we got a B and a B squared and a B there. We're going to use the B squared. We've got a C to the fourth power. There's no C here, so that's what we're going to use. So we've got a D and a D and an E. Okay, both of those have a power of 1. So for variables, okay, the least common multiple is going to be A cubed, B squared, C to the fourth, D, and E. All right. Just that simple. So now let's move on to polynomials. Suppose you have fractions where these are your denominators: x squared minus 1, x squared plus 2x plus 1, and x minus 1. Now before we can actually find the least common multiple of this one, we have to break them down like we broke down these numbers up here. Okay. Now to break these down, we're going to use factoring. There's different factoring methods. They're called different things. All right. So, but the concept is still the same. We have to break them down, find their factors, and then put them in the LCM. All right. So we're going to start with. We're going to go ahead. I'm going to write this stuff down here. X squared minus 1, and then the other one is x squared plus 2x plus 1, and then x minus 1. So these are our numbers that we're trying to break down. Okay. So we can find their factors. Now let's start with x squared minus 1. So x squared minus 1, okay, to break that down, we use what's known as difference of squares, and that's a whole nother topic to get into. But breaking this down, we use difference of squares, okay, and basically this becomes, we find the square root of this, which gives us an x, and the square root of 1, which gives us a 1. And there is a formula for this, by the way. You can look it up in some other videos. It's called the difference of squares. So anyway. This is a plus, this is a minus. So this broken down becomes this and this, all right? So here we go. That's going to be, so my factor is going to be x plus 1 and x minus So now we've got that one. Now for the other one, okay, this next one right here, okay, let's go ahead and factor that. So that's going to be x squared plus 2x plus 1. Now the way we would factor that is basically, we call it a is equals to 1 factoring because the number here is a. The number here is a 1, I'm sorry. And so we break that down using what's known as, we call it a is equals to 1 factoring. Now, the method is to find these numbers, we put an x and an x here because that's an x squared. That's our variable we're going to use. Then we look for two numbers. When we multiply them together, we get 1. And when we add those same two numbers, we get 2. And the only numbers are plus 1 and plus 1. Okay? We have 1 times 1 will give us 1. Okay? 1 plus 1 will give us 2. And that's the numbers that we use here. And once again, that's another video. So, but this is broken down, this polynomial is broken down to x plus 1 and x plus 1. Since they're two of the same kind, we're going to rewrite this as x plus 1 quantity squared. So this is x plus 1 quantity squared. Alright? Now, we've got x minus 1. Now looking at x minus 1, if you look at it, it is not factorable. So we cannot break this down anymore. This is actually a prime number. So this remains the same. It remains x minus 1. So now what we've done is we've found all of our factors for all the different numbers or the different polynomials that we're comparing. So all of these are our factors. So now all we need to do is find the least common multiple. So let's go ahead and do that. So the least common multiple, we go back to our rules. All factors must be represented once. Right? There's an x plus 1 and an x plus 1 right here. You guys see that? So we're going to write that just one time. Okay. Right? There's an x minus 1. There's an x minus 1. There's two of them, but once again, we're only going to write that just once. Okay? And then what else? Do we have any more? X plus 1, x minus 1. That's it, right? Okay? So now what we're going to do is we're going to follow the second rule, which is the factors with the highest power is what we're going to use for our least common multiple. There's two x plus 1s. Only one of them has the higher power, which is this one. So we're going to use that 2 for that x plus 1. And it's x minus 1. They both have a power of 1, so that remains the same. So technically, this is our least common multiple. Okay? Now this may be rewritten some other way. It might be written as x plus 1, since there's two of them, x minus 1. Or we might get a polynomial which all of these numbers are multiplied together, which is some lengthy polynomial that I don't want to get into. Okay, that's a whole nother lesson. But anyway, this is our lesson for today.